Hey, Dr. Fiegel, Rick here again with my assistant Sebastian. We're in the town of Bad Schwabach in the Taunus Mountains in Germany. So Bad Schwabach, as early as the 1500s, was known as a health resort spa town where people would come and just kind of relax. Here we have a fountain, which I thought would be a cool place to collect a water sample for our lab this week. The mountain is known as the Steel Fountain, and it actually is supposed to have the highest iron content of any other spring in Germany. So we're going to take an example. I don't think our lab tests for iron content, but nonetheless, I thought it would be a cool place to get a sample. Come on, Sebastian, let's get some water. So the water is carbonated. Naturally carbonated, supposedly. I tried drinking the water maybe a month back, and it's disgusting. It's like sucking on a copper penny. But we'll collect a sample. All right, close it up. All right, give me a thumbs up. Come on. There she is. All right. Back with our lab. Now we're testing nitrate. I went ahead and added the 2 nitrate pills and shook them up until dissolved. We can see that they're starting to change colors a couple of minutes in. Sorry for the background noise. We do have a little Sophia newborn and my assistant Sebastian, who just took off on a break. Before taking off, he said this was looks like stinky water, which it kind of does look like dirty water after the pills have dissolved. So same as phosphorus, nitrates are critical for both plant and animal growth. However, when introduced to bodies of water, the overabundance of phosphorus and nitrate in particular can cause algae growth, like rapid algae growth. And what happens when the algae dies and decomposes, it causes a process called, I forget, eutrophication, and basically is a lack of oxygen. I think we know it as well as hypoxia. Hello, Dr. Fiegel. All right, so you've seen my introduction. You saw where we got our body water sample. It technically wasn't a body water, I guess, right? It's a natural spring in our town. You saw my setup for my project this week. I cut down a ton of video because I recorded the whole thing. It was way too much. But we'll kind of conclude with answering some questions of what we learned this week in our lab. Again, thank you very much for my extension. Got a lot going on here in the Hernandez household with a newborn. Coronavirus here in Germany is taking a toll, and just work and life things. But anyways, why is it important to maintain water quality of environmental water sources? We can't recreate water, right? Well, we have what we have. Water is necessary for the survival of humans and plants on this earth. So we have to do our best to make sure we're not contaminating or contributing towards environmentally damaging our water sources. Water quality can be compromised by 2 main methods of pollution that we learned in this class. These are point source pollutions and non-source point solutions. Point source pollutions occur when contaminants from a single identifiable source, such as farmland, irrigation runoff, discharge from the discharge pipe from a factory or somewhere we can clearly identify where the source is coming from. Now, this wastewater from point sources is monitored because we know where it comes from and regulated by governmental agencies. And in most developed nations, some third world countries, not so much, so it's a big contributor towards the pollutants. And then non-point source pollution. Non-point source pollution occurs when precipitation runoff collects contaminants from multiple sources such as roadways, lawns, farmlands, and industries flowing into a water body. Now, all this runoff, all this rain precipitation happens. It washes away the oils on the street. and it goes into then it flows into rivers eventually, and causes the pollution. And this is the most common way that developed nations contribute towards the pollution of water on Earth. In the U.S., the EPA, the Environmental Protection Agency, sets and maintains standards for water quality in waterways, effluents, and drinking water. And also at a more local level, there can be more stringent laws and regulations. Now, in all the tests that we conducted, all of the water samples were safe to drink. In some cases, the spring water was actually more favorable to drink, especially for nitrate levels, which came in at 10 parts per million than the tap water. So the tap had a 10 parts per million. And actually, in the U.S., the EPA has set the maximum nitrate levels allowed to be in tap water to the 10 ppm we're running at our faucet here. Yikes! Something just to know. We have a newborn. We always make sure we use bottled water, or at least boil our water before we make bottles. But it was something kind of alarming to us as parents. In the 4 tests we conducted, phosphates were the least important for determining if water was safe to drink. Why? Because a high phosphate content poses zero harm to humans. It is actually not even regulated by the EPA in America. This is because the body actually needs phosphorus to build and repair bones and teeth, help nerve functions, and also make muscles contract. In fact, they were once common ingredients in water softeners, phosphorus that is, and this practice is not as prominent anymore because of environmental concerns. So far, phosphorus was the least worrisome in all the tests we did. Nutrient pollution is one of America's most widespread, costly, and challenging environmental problems, and is caused by excess nitrogen and phosphorus in the air and water. Now, nitrogen, I think, is abundant in the air we breathe, so it's a very, very common element. But when concentrations in the water, it could be detrimental to life. Nitrogen and phosphorus are nutrients that are natural parts of the aquatic ecosystems, right? They're there. However, when in large contents, it could cause the algae bloom, as it's known, where algae just kind of grows out of control, dies, decomposes, and it kills off the oxygen, killing off the aquatic life. What else? The quality of water discharged by springs can vary greatly, because maybe I should read the question, because I'm kind of going off here. So the question was, list 3 potential sources of pollution in your water body sample. So 3 potential sources of pollution in my water body sample of a spring are, we've got the types of rocks with which the groundwater is in contact, because it's a spring, so that the minerals in the rocks can dissolve and brought up with the spring water. Also, the quality of the water can also be affected by the mixing of fresh water with pockets of seawater in the aquifer or the spring. This is obviously more common along coastal areas. And finally, shallow aquifers or springs are at higher risk of nitrogen contamination due to their proximity to surface water and runoff. Of course, I picked a spring. Maybe it would have been easier or better if I had gone with maybe a lake or a stream, because then we would have been able to find more pollution. Maybe the coliform bacteria that we tested. All of those came back negative for even my spring water. But this concludes my video and my week. Definitely learned a lot. It was a good week. It was a long week of looking after our water samples.
but learned a lot.